This is a revision course on distance, time, speed and acceleration. I'm going to start with giving you an overview over the different units that we use. So let's start with the basics. We have the distance and we have the time, then we have the speed or velocity, and we will come to the difference in a moment, and we have acceleration as well. Now I want to look at the different symbols or the different abbreviations that are used for each of these categories. And the different symbols are, for these here, for the distance, I usually use small d. It's important that you use a small letter. Small t stands for time. The capital T would stand for temperature, so you want to use the small t here. Speed or velocity is abbreviated by a small v. Again, capital V would stand for the volume. And acceleration, a small a. So all of these letters are small letters. So these are my symbols. Now the question is, what do you actually measure all these quantities in? And those would be the units. So the distance could be measured, for example, in kilometers, or you could talk about miles, or you could talk about meters, or maybe centimeters. So there are different units. The mile is part of the imperial system, so I'm not going to list that here. The time could be measured in hours, it could be measured in minutes, it could be measured in seconds, you could even talk about days, years, etc. Speed and velocity could be measured in miles per hour. Again, I'm not going to list this here because we don't really use it in science, but of course it's used, for example, in racing in the UK. You could talk about kilometers per hour, and note that I'm writing here kilometers/h to mark that it's per hour. So it's how many kilometers you do in 1 hour. In science, what we use a lot is the meters per second. Acceleration would be measured in meters per second, which is the meter per second squared mathematically. There's something known as the SI unit. The SI unit is the System International, International System unit. This is something, these are units that scientists agreed on using all over the globe. And the idea is that it's easier to communicate with each other. So this is how it works. The SI unit for distance in physics would be the meter. For the time, it is the second. And all these other units would then be based on that. So meters per second is based on these very basic SI units. So this is the overview over distance, time, speed, velocity, acceleration in terms of the symbols that we use. Now let's have a look at the formulae. And I'm going to extend the page here a bit. Now, first of all, you have the formula: the speed or velocity equals distance divided by time. What does it actually mean? When we talk about speed, it means that we are moving, or an object is moving, a certain distance in a certain amount of time. So what this formula stands for is how far does the object actually move in, for example, 1 second. How far does it move? Now, if something has a higher speed, it means it would move a larger distance in that 1 second. So I would get a larger value for my speed or velocity. So I could put in here, if I have someone who runs a 100-meter sprint, and say it's someone who wins a medal in the Olympic Games, these guys run it in about 10 seconds, the 100-meter race in about 10 seconds. So if I use that example, I would have my 100 meters for that race and divided by the time, and the time would be 10 seconds. So what I get here is 100 divided by 10, and that gives me 10 meters per second. Sometimes my units are different and I can't just get my meters per second. Sometimes I could have a situation that I have, for example, my marathon runner. If I want to know the speed of a marathon runner in meters per second, well, I know that the marathon is 42 kilometers roughly. It's a tiny bit different, but this is a good enough approximation. 42 kilometers, and the fastest ones take around 2 hours. Now I could say this is 21 kilometers per hour. This is of course right, but maybe I actually want to calculate it in meters per second. So in that case, I need to convert the 42 kilometers into meters. Now 42 kilometers, kilo stands for 1000, makes 42,000 kilometers. And the 2 hours make 60 minutes per hour and 60 seconds per minute. So I have 2 hours times 60 minutes times 60 seconds. So that gives me, if you key that into your calculator, you would get 42,000 divided by 7,200. And if I do the maths on this, then I get 5.83 meters per second. So here's my answer in meters per second. And what I need to do is convert the kilometers into meters, convert my hours into seconds. Now sometimes I might want to find the speed in kilometers per hour, but what is given to me is something like minutes or seconds and for the time, and the distance might be in meters. So in that case, I need to do the conversion just the other way around. Now let's take an example where I have 2,400 as the distance, 2,400 meters, and say my time would be, in this case, say 3 minutes. Now I want my result to be in kilometers per hour. So I'm writing down my formula V equals d over t. My distance is 2,400 meters and divided by 3 minutes. Now if I put the units behind here, then it becomes a bit more apparent what I'm actually doing. I need to divide the 2,400 meters by 1,000 because there's 1,000 meters in 1 kilometers, and I want to go from meters to kilometers. So if I do this on my calculator, I get 2.4 kilometers in 2,400 meters, and in 3 minutes, well, there's 60 minutes in 1 hour. So I need to say it is 3 divided by 60 minutes. This is 3 over 60 is the fraction of an hour that I have. So I get 2.4 divided by 3 divided by 60. And I can calculate this, put it into the calculator, and I get the following answer. And I get 49 kilometers per hour. There we go. Now you might want to rearrange what you've been given here, this formula. You might want to rearrange that. For that purpose, you could draw the formula triangle. So what we have is V equals d over t. If you want to find the formula triangle for this, because you find this easier to use, then whatever is at the top, like the d here is at the top, you put on the top. Whatever is at the bottom, you put here at the bottom, and in the remaining space, you will now put the letter that is remaining on your left side of the equation. So if you want to rearrange the formula and find the time, for example, you would just cover the t. If you cover the t, then what you're left with is d at the top and v at the bottom. So this would give me the formula to find the time. If I wanted to find the distance, I would take the distance from the top, cover the top, and what I'm left with is v and t at the bottom. So I multiply v and t, because between v and t there's always the multiplication sign. So with these two new formulae, I could now find the time in a question or the distance in a different question. So let's move on to acceleration. The formula for acceleration is the change in velocity divided by the time. And the change in velocity is always represented by a delta sign. Delta V stands for the change, and this is divided by the time. So what does this actually mean? If I have a car that accelerates at the traffic lights, then the car starts off at a speed of 0 because it's stationary in front of the traffic lights, and then it accelerates, say, to a speed of 50 kilometers per hour, which is something between 15 and say around 17 meters per second. So it accelerates, and there's this change in the velocity, and if I divide that by the time it takes, then that gives me the acceleration for the car. If I have a very powerful car, it would actually get to this higher speed in a shorter amount of time. So my acceleration would get a larger value. So let's look at an example here. If I had a car, and let's use some simple figures here. If I had a car that starts off at 0 and it goes up to 20 meters per second, and let's say it does this in a time of 5 seconds, then my acceleration would be 20, because the difference between 0 and 20 is 20, divided by 5. And that gives me 4 meters per second squared. It's a second squared because I have meters per second, and mathematically that's the same as meters per second squared. There's also another way of writing down this formula, which would be the change in velocity is my final velocity minus my initial velocity, and divide that by the time. V minus u, v would be the final velocity, and u would be my initial velocity. Now you see that for the example that I had up there, I would actually have 20 minus 0 divided by the time, and the time in this case was just 5. So here we go, and of course I do get the same answer as before. So this is the other way of writing this same formula. If I want to use the formula triangle for this, then I do need to do the following. Again, I'm going to put at the top whatever stands at the top. So delta V would go to the top, and it would be followed at the bottom by T. And instead of going the vertical line, I can also put the multiplication sign in there and write it like this. Alternatively, you can write it, of course, as v minus u, and then put again t and a at the bottom and write it this way. That will give me exactly the same, because delta v is equal to v minus u.